think we are live participant and thank you very much again. So today live session, which is 15th live hour. So this is 13th live testing. We have solved plus questions. So through these are my goals in the live stream. So questions. Clean. So what let me open gate overflow aspects to perform. Okay, and wait to exam session which element to write isolation. So just one from due to what mechanism my setback in J across. What? Okay, let me read this out later. Examination is test okay test. After test. No, so it's test. Topic like such 6 marks. 6 questions, 8 marks, 14 minutes, 12 questions. Oh, I taken this fine. One code, no hash, you such green, other no year to choose result in terms of such as frequency of results. Okay, this is about the sessions. Algorithms, okay. So which shall choose database and taken. Okay, they're taken. Okay, one taken. Oh, not taken. You search for candidate keys. If you have taken these two tests, functional dependencies, okay, this statement and okay, so next. Think in Boolean algebra identity, right? To the limited system degree. Yeah, I have taken. Okay. Okay, so yeah. It's not about text, so it's about what are books. Books, okay, books. Yes, you can we choose digital logic, boundary code. I don't know, I'm doing so much English learning. Okay, real function. Let me do this question. If also believe the function of x function of x is equal to this then I recognize acting same expression of less and if f is said to be self-driven with applicable the number of self functions in yeah. Okay. So if we take this n but trying to like very Boolean variables. Boolean variables you can set there are n power no there are 2 power n functions. Married 2 power n. Yeah. Reveal the answer. I think so. This D. Yeah. D. Let me see this thing. Okay. Okay. So we will explain. Duplicate on planet islands was for the duplicate for Vista. Okay. What they're saying. Number of pentums of equal map. Okay. A function is self to L if it's equals to dual. Okay. A dual function is obtained by interchanging dot and plus. That's all for self-L functions. Number of minterms equals to number of mixed terms. A function should not contain two complementary minterms whose sum equals to 2 power m square minus 1, where n is number of variables which is one function. Okay. So there is 0, comma 7. What is 0, comma 7? 0 and 7 is self-tail because ingestion percent there is 0 of that and 1 comma 6 comma okay have compulsory terms. So in self-tail we can select any one of them but not both. Okay. Totally told to do for possibilities because from 0 to 7 there is 2 for 4 possibilities and pick any midterm but not 4. No, here I have taken only one of the complementary terms. Then for me, so this so remaining but will go to max terms. Okay. For the example, for equal 60 self-fair functions are possible. Okay. So if we have n variables, total midterms possible is 2 power n. Yeah, this is what I call total 2 power n. 2 power n is midterms. Like midterms is also equals to maxterms. So, okay. So then half of them we select. So this half of them. To put it right, what is it? If we take n, it is 3 variables. So we select n to parameters of okay. Now we have two choices. Which way is selected? So to such as which tool to example. N equals to 2 for n. Okay, let's say n equals to 2 for 2 to Boolean functions of possible. And it's 2 for 2 for 2 Boolean functions of possible. In this self-dual functions of 2 power n minus 1. Okay, so that is 4 self-dual functions are possible. Okay, set from 0 to 1. Okay, and for what is self-dual 0, it's converted to 1, 1 converted to 0, and dot converted to plus. I mean, not plus, like plus converted to into, and into is converted to plus. Okay, well, like this. So complement is not converted to anything. Okay, just let me have some. Mm, taxis. Okay. Fun one is currents. AB. So, for suppose okay, is taken equals to per n to per so how many non-self-tail functions? It means that we know self-tail functions, right? So we can take simply 2 power is equal whole functions minus self-tail. The self-tail means what? 2 power n minus 1. This means self-tail function. So it equals to non-self-real functions. Okay, fine. So we just have to remember two what foreign functions are there. So the next two elements from self-real functions are there. A equals to b equals zeros. Okay, if two variables are there, we set possible only for what is to finish. Okay, a b is b. Okay, as I explained above in the answer here, 0, comma 3 are self-real functions. Okay, 0 and 3. Yeah, 1, 2, and 1, 2 are self-complementary terms. A self-complementary terms. Likewise, another fine. Here, four possible self-real functions are. Okay, f1 function 0, comma, okay, 0, comma. What is 0, comma? How it is possible? 0, comma, self-real 0, what is 0 and 1 self-real 0, comma 2. Four possible self-real functions are. Observe in each of the functions, one term is chosen from the complementary pairs 0, comma 3, and the second term is chosen from the complementary pair of 1, comma 2. And let's say 0, 0 means full zeros, that is a bar plus, and 1 means what this. Likewise, 1, 3 and 2, 3 and head. Such stream has x. Let me know. Let's take one check. Yeah, that times. So what we have to say for limits. And this thing is fun. Okay, there are here four possible serial functions. 0, comma 1, okay, 0, comma 1, okay, 2, 0, here. What should be 0, comma possible. Observe each term of the function. No, I think they have to link into serial functions. It's getting complicated. You know. Okay, so, and so Excel real then real function electronics.
A function is said to be self-developed.
So
Let's see the self-dual functions. A self-dual function is one. Okay, with the example it will be clear. Let us say this is a function in a, b and c. ab plus bc plus ca, it is a function. And now find out the dual of it. I hope that you remember what dual is. Changing plus to dot and dot to plus, and then changing 0 to 1 and 1 to 0, but then leave out the variables as it is, right? So leave out abc's as it is just to change it. Now change this dot to plus 2 dot, like that, right? Then I got this thing called as a dual function. Now if you look at these two, f equal to fd, right? So whenever a function is equal to its dual, then it is called self dual, right? So one thing is, once we got the self dual, what I would like to know is, what are the types of functions which are actually self dual, or are there any properties?
let's see. Let's see. Okay. 6
Now a dual function. Now if you look at these two, f equal to fd, right? So whenever a function is equal to its dual, then it is called self dual, right? So one thing is, once we got the self dual, what I would like to know is, what are the types of functions which are actually self dual, or are there any properties in the function which will make a function self dual? So in order to observe this, when we have examined all such self dual functions, we found out two things. So see this, let's examine this one first. Now at this level, it is difficult to analyze it, therefore I am going to convert into canonical sum of products form. What is canonical sum of products? We have to expand every term in such a way that it is a min term. So in this AB, C is missing, therefore I am adding this, and in this BC, A is missing, I am adding it, and in this CA, B is missing, therefore I am adding it, and now I am expanding it. So when I expand it, I got these terms, right? And when I expand it, I got more terms, but then some of the terms are repeating. When you remove the repeating terms, this is what I got. It is nothing but canonical sum of products. Now observe this. In three variables, how many minterms are possible? 8 minterms. But how many minterms are here? 4 minterms. So whenever you have any function with number of minterms equal to 2 power n minus 1, the total number of minterms possible is 2 power n, and if any function contains the number of minterms 2 power n minus 1, it means that we have taken half of the combinations and for them we have assigned 1, and for the remaining half we have assigned 0, right? So that is nothing but a neutral function, if you remember it, right? Therefore it is a neutral function, first thing. And second thing is, there is something called as mutually exclusive terms. If I have a min term, a mutually exclusive term can be obtained like this. Say I have a min term like this. The min term I have is ABC. Then mutual exclusive term for this min term is A prime, B prime, C prime. Similarly, if I have the min term A, B prime, C, then the mutual exclusive term for this is A prime, B, C prime, right? So likewise, these min terms, after finding out the difference between the original term and the min term, just see all these terms and try to find out the min terms for each term. What is the min term for this? A prime, B prime, C prime. What about this? A prime, B prime, C. What about this? A, B prime, C prime. What about this? A prime, B, C prime, right? Therefore, check this. If ABC is present in the function, then its mutually exclusive term A prime, B prime, C prime is not present in the function. Check that. Similarly, if A, B prime, C prime, A, B, C prime is present, its mutually exclusive term is A prime, B prime, C. It is not present in the function. Similarly, if this is present, its mutually exclusive function is not present, right? So, if any variable, if any term is present in the function, its mutually exclusive term is not definitely present in the function. So these two are the characters required or essential, sufficient, necessary and sufficient for a function to be this self-dual. So depending on those two rules, we are writing like this: a Boolean function is said to be self-dual if first thing is it has to be neutral. Neutral means the number of min terms should be equal to number of max terms, but it is just necessary. It is not sufficient, and you have to add one more condition. So what is the other condition is the function does not contain two mutually exclusive terms, which means it should be neutral as well as two mutually exclusive terms should not be present, and these two independently are necessary, but they both have to be present in order to say that a function is self-dual. Now the interesting question is how many self-dual functions are possible, isn't it? That question might arise. Now let's see how many self-dual functions are possible. Let's analyze that.
Oh, what's this?
Now let's see how to derive the number of self-dual functions possible. So for that, let me take the example, it will be easy. If I take the example and derive it, it will be easy. Let us say I have three variables a, b, c. Then how many combinations are possible? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. These are all the min terms possible, total min terms possible, right? Now in these min terms, let's just number them, it will be convenient for me to represent it. It is 0, it is 1, it is 2, it is 3, it is 4, it is 5, it is 6, it is 7. Now check the min term 0, which means 0, 0, 0. What is the mutual exclusive term for that? The mutual exclusive term is 1, 1, 1, isn't it? If this is the min term 0, 0, 0, then the mutual exclusive term is 1, 1, 1, right? So I am just keeping them in a pair, 0, comma 7. These two are mutually exclusive, right? And similarly, if I have 0, 0, 1, what is the mutual exclusive term? 1, 1, 0, which means 1, comma 6. And if I have 0, 1, 0, what is the mutual exclusive term? 1, 0, 1. So which is nothing but 2 and 5 are present in one pair. And now if I have 0, 1, 1, the mutual exclusive term is 1, 0, 0. So which is nothing but 3 and 4 are in one pair, right? So now in order to form the self-dual functions, one thing is the number of min terms should be equal to number of max terms, and moreover, if we have assigned
Min terms equals number of max terms. Next.
a 1 to a term, then you should not assign 1 to its what is that called? The expression is complement, right? Mutual exclusive term, sorry. So if the terminology is like this, the mutually exclusive term to 0 is 7, the mutually exclusive term to 1 is 6, right? So the concept is like this. Now the number of min terms should be equal to number of max terms, which means there should be exactly 4 ones for any self-dual function. And second thing is, if you assign a 1 to any min term, then you should not assign 1 to the corresponding mutual exclusive term, which means if I assign 1 to this, you should not assign 1 to 7, right? So now other way of forming it is, what I do is I'll make all the terms into pairs in such a way that each pair contains a min term and its mutual exclusive term, and now I form a function. How can I form a function? I could choose one of them, and I have to choose exactly one of them. So from 0 and 7 I can choose only one. So you could either choose 0 or 7, therefore 2 chances are there, and you can choose 1 or 6, 2 chances are there, and you can choose 2 or 5, 2 chances are there, and you can choose 3 or 2 chances are there. What does it mean is, if you can pick 0 here, 1 here, 2 here, 3 here, it will definitely be a self-dual function. The reason is number of min terms equal to max terms, and then a variable, a min term and its mutual exclusive term is not present, right? So just to make sure that this happens, what I'm trying to do is I'm going to make them into pairs, a min term and its mutual exclusive term. After making them into pairs, how many such pairs I got here? 4 pairs. Now from each pair I have to choose exactly one element in order to form my function. Therefore my function will have how many chances is, one is it has 2 choices here, 2 choices here, 2 choices here, 2 choices here. Therefore how many self-dual functions are possible here? 2 power 4, which is 16 self-dual functions are possible if I have 3 variables. Now if you look at how I derived it is, first of all I have written the entire table, then how many rows will be there in the entire table, which means if I have n variables, then how many minterms are totally possible? 2 power n. Then what I did is I have paid each minterm with its mutual exclusive term. Then how many pairs are possible? Number of pairs equal to 2 power n minus 1. Now after taking all the pairs like this, from each pair I have two choices to make the function. Therefore I can write 2 into 2 into 2 into so on 2 power n minus 1 times, right? Therefore what do I get? I get 2 power n minus 1 like this. 2 power n minus 1. So try to understand this. How did I get this 2 power n minus 1 is, I have 2 power n rows, out of which I am taking the pairs. Each pair is going to contain either a minterm and its mutual exclusive term. Then how many such pairs I got? 2 power n minus 1. Now once I got all these pairs, then my function is going to include one of the element from each pair, and definitely one should be included, otherwise that rule, what is the rule? It has to be neutral, right? That rule doesn't satisfy. So therefore I have these many pairs, and every pair is giving me two choices. Therefore how many functions are possible? 2 into 2 into 2 into so on, number of pairs times how many pairs are there? 2 power n minus 1. Therefore total number of functions is 2 power n minus 1. This is the formula for the total number of self-dual functions possible with n variables. Got it? So just remember it. The number of self-dual functions possible is these many. Now we have already seen that there is something called as neutral functions.
So what here is asking? Okay, what's the question? The 12 of Boolean algebra effect. What is this complement? What is complement? The is same expression. Replacement dot average. Okay, if the number of self-dual functions of Boolean variable is okay. So according to example like option D. So, and very draw. So here, not like so for it so. Right, okay. Yeah.
How did we find the neutral functions? Just see this. We have already seen the neutral functions. Neutral functions is nothing but if I have 2 power n min terms, I have to exactly choose half of them to be present in a function. Then how many functions are possible? From 2 power n min terms, I have to choose 2 power n minus 1. So this is nothing but the number of neutral functions. And now 2 power n minus 1 is nothing but the number of self-dual functions. Which one do you think is greater? So what is the relationship between self-dual functions and neutral functions? If a function has to be self-dual function, first of all it should be neutral function. But then if a function has to be neutral function, it need not be self-dual function. Which means if you look at this set, let us say it is set of all neutral functions, right? Then the set of all self-dual functions will be here. Therefore every self-dual function is a neutral function, but then every neutral function need not be a self-dual function. Got it? This is the relationship between neutral functions and self-dual functions, right? So obviously this number will be greater than this number because this is a set of all neutral functions possible, but this is just the set of all. Yes, for some value of n it might be equal, but once you grow the size of n, this number will be greater than this number because every neutral function cannot be a self-dual function. Got it? One clear example. See, if you want to know any example of a neutral function which is not a self-dual function, maybe you can take a function to be like this. If you include a term and its mutual exclusive term inside the function like this, let us say if I include 0, along with 0 if we include 7 also, and then 1 and then 2, right? A function is a min term is present and its mutual exclusive term is present. Here itself it failed, therefore this function cannot be self-dual function, right? But it is a neutral function. Why? Because out of 8 min terms you have chosen 4 min terms, therefore every function which is neutral may not be a self-dual function. But then if a function is self-dual, it will definitely be a neutral function, right? Keep that in mind.
And the present are also depend 60. Okay. People take or advance. Much three or three was variable from one to equals to relate to power to parameter self function. Okay. The nodal function. Nodal function can be 0, 7. Okay. 0 is nodal function is nodal function. Okay. So it can present anything. So after this, so we have total two current functions. To this we have nodal functions to power and minus 1. These are nodal functions. Right? Nodal functions. Good. It. So here, next question. So here, options to power. Power 2 for MFS are self functions. Fine. Got it. Then could have written one question and finite set. Got this finite set state missions. Okay. It's for 41 question attribute came up. Came up, right? Written came up. No, right. Let me do some problem came up. There are totally 15 questions. Total 20 questions came. Let me do questions came up. Oh, take it. Next total 27 minutes we have left. We have 27 minutes. 15 questions. Oh, from marks. Okay. 15 questions. Like each question doesn't get more than 1 minute 30 seconds. So let us do content. So okay, right. I got this right. Okay. It's okay. Right after the time. Right. So we have taken in process concise for that's okay. Oh, it's okay. Take test. And to be very quick. Let me do that. I'll get another question. Okay. Okay. the following expression. Which of the following action does not correspond to one of the expression? Sure. Oh, that according to we means okay, the minute means 4 down. Oh, okay, taking some time, so function that not treatment, take not function that's a implement. Okay, so let us take out the simplify these four terms we get brackets. Simplify those four terms, what we get. So these four terms we get is the what I mean like W W is these two where y is common okay wy plus this one and if we okay let's these two and if we do all this one and that's the we get what plus xy okay if we take y common with w plus x okay w plus x is okay and which is wy wy plus x okay so what else if I take what suggest in terms simplifying is what we can do what w for 0 w bar x plus w bar y if you do so this y becomes 0 and should become w bar y x bar plus w bar y. So if we take w comma, what will get? What will get? If you take w y comma, we get this one. So w bar y is the answer. So there is a none of the also is there. So how it is possible? It's just w bar. So what is w bar? W bar means what? W bar means here these two. Okay, and y. What's y? Y means here these two. It's completely false. Think option C will be okay. So next, which of the following function implement the common option below? To the following, let's see question. This is why we will do all this one. We take all this one. What should I do? CD with CD plus we take this whole bar. We get what we get. Let's take this whole. And so this okay. Okay, AD plus CD. Okay, AD plus CD. Okay, and we will be also. So the following implements the kernel point. Okay, AD plus CD. Think, yeah, it's just true. AD plus CD. The Boolean functions in SWP form came up with given field. The Boolean. Okay, what? Where is AB? Or where is option? The answer. The Boolean function if came up given. What is the Boolean function? What they're saying. So it's what A plus A bar becomes from just talking just just the marker and what is the minimum form of K-map should below assume X does not get what is the minimal form of K-map of minimal form. If we take this okay it's possible and if we consider taking this one okay if we take this one what will get? We'll get 0 means C bar, C this is 2 and we get C bar and this is actually AB. C bar AB. Okay. You take this. No, we can take this term and this term, right? Okay. What's the property here? Here common is C bar and the common is B bar. Okay, C B bar. C B bar is committing or we'll take all common. Okay, this term is committed. What we have to take this. We'll take all common. We're going to take common 0. That's D bar here and here B bar. Okay, B bar. Okay, B bar common. Okay, B bar D bar plus C bar B bar. Okay. B answer. So if F equals to okay, means also F2 F1. Okay, we got F1 min terms. Okay, and F2 max of C1 if alpha comma beta and gamma denotes the respect to sum of number of implicants, prime implicants, essential prime implicants of F1 and F2, then alpha comma beta, alpha minus beta plus gamma. Yeah. And then like I'm not with implicit and vectors concept. No, I shall just keep it. Okay, minimal sum of product expression for F of so here. Sum of product. If we take okay. If we take these two and these two, that tells him so this is common in between. 0 means Z bar, Z bar, and X. Therefore, and X. Yes, therefore, and X, and what is common between these two? Common between these two, we get what? Z. Z X bar. Okay, yes, this will be Z X Z bar. Z X bar. Okay, so what is kind of X doesn't get down. What is the minimal form of function that will come up from here? So how can we do minimal form? We'll take all these terms at once and we'll do these two. And we consider taking these two and these two. That's it, right? And then what finally these two. And we can scan on. Okay, if it's taking if we consider these two terms as well. So what is the commonality between these two? But commonality between these two. A bar, okay. Plus 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 that. Yeah, called BB. Not to depart, depart, say about depart. The function represented by the document given is your function of what valid function. So this function so automatic. You have to take it. Get the command. Just that's it. And what we take these two. Commenting. No, we can't take one because here the function is just inverted. Okay, now it's going to take SBC plus V bar plus BC, that's it. It will become BX nor C. Then it can also be BX or C whole complement. Okay, nice question. The literal, okay, the count of units and sum of income steps. Okay, let me do this question and mark for you later. And with what equal be something POS. Think what is the expression product of something? They can sum up for product of something. So we touched on this is true. Just have to do zero right. What is the equivalent full expression in product of sum of k? Okay, like given for if consider these two and we will delegate with commonality, we will get D, okay, D, okay, D, I need to convert it to get B bar, DB bar, okay, DB bar plus, right, wait. I'm getting these terms and actually I'm doing wrong, yes, links, but okay, let us just see convert. We'll see match it up. Okay, what is this? Okay. Series complex debug of debug. Execute this will become what is going to be okay. Let's see just X. So if you want to take so you get what B plus B dot G plus B dot. I think to be the correct answer, but I'm not sure if I will. But okay. I need to take these terms and stop this time, this one, this one, this one. So we okay, no, let's do the correct process. We consider all zero terms of the effect. Then what is term here? We'll get here, we'll get these two terms. Okay, this term is here. So upper term be A, okay, it's 0, 1. So one is here, B. So here we'll click on B bar plus, and these two, what is one is common. So what happens here is B bar. Is this true? No, one means D bar, right? D bar. Correct. Here, what is coming here? Okay, one means B. Okay, zero means B. One means this complementary terms. There's no time to tell, but there's not time to sit up. Think sad. What does people so? Okay, just James want just James just talk. James bar. A plus B bar. Okay, here's C plus B bar. Here it is A bar plus B bar. That's all. Okay, here what we get it. B bar plus here D bar into What is this bottom? Bottom. But here this bottom d bar. Okay, d bar. D bar. No, here it is 0, right? It will become D. Okay. D. Here, what's common term? The common term is 0 again, 0. B. Okay. So, yeah, option C. Okay, so given the following game, which is for questions, SOP. SOP is good. Then again, okay, what here one is there, here one is there. If we take this whole bus, it's what will be the answer? What is the common term? Common term is just x. Okay, x. How can it do? It is zero, right? We can't take. Either we can take this and this one, and if we take this one, take this one, what will be the answer? What is the commonality between that? What is the commonality between this? Become y. Okay, y, y. Combines this one, and this is x. Okay, yx, and double is it what y bar is it y bar, and it is z. That's it. So xy plus y bar z. Is there any one? No. So then what? The Boolean function. Okay, the Boolean function for combination circuit for the four inputs like in a function. So what is the product of what? Okay, which of the product term gives the below essential complementary function? Literally, like this question. Then the following question here. Which of the following keyword correctly represent? Oh, so there are totally four sources of 4K, 4 variable came here. So there is a D bar. So first of all, you have to take a D bar. So A means this. A means this one. B means this one. This one, this two one should be present. D bar. D bar means what? D bar means yeah, this one and this one. So there is something different in these two. I mean, okay, there is something different in these two. What? And there is something about these two. Okay. So yeah, we can say every term is present, right? So first we can say everything is present. It is A bar, C bar. So A bar means in this, and C bar. C bar means what? C bar means here. C bar, here it is C. And again C bar. These two should represent everything. Okay, these two present everything. This is wrong, and this is correct. This is correct. Okay. So option B is wrong. So here B, C bar D. Okay, B. Where is B? Here B. Okay, between these two we have to take one. Okay, then C bar. C bar means here. Okay, C bar and followed by D. C bar D. Where is C bar D? C bar D. Yes, it will be the C bar D in this line. I think these two will be. Okay, see. These two will be there. These two will present. Okay, these two. Okay. Okay. Everything will correct, right? Correct representation. So then what about this? This one is actually extra. So if I'm not wrong, okay, it will matches. Okay, and what about this will matches. This, so what about this? Will matches this. So oh my god. Actually, there is not much difference right for Alex and 3x. 3x not of okay, right? No, these three are same. Here the x is there. So yeah, this is false, and we consider these two Consider these two. Okay, okay, A is correct, right? Because we just know this. So yeah, like if we consider A bar C, okay, here is A bar means here and C bar this whole term. Kind of optional will by transfer. Mhm. Okay, the Boolean function here is to be what is to be realized only by NOR gate. Okay, NOR gate. It schema is given below. Okay, what is schema? You have to find part of the schema. Okay, I just want to you can just do group circle with what we get. So what is common between these two? Mm, means only A plus here this one the program creates makes it total. It is here it is C C minus 1 means V. A plus CB. So so we will find A plus CB. So take A, this market rate, how can we find? Take A become market. Okay, market will become A bar and BC. B, okay, fine. BC is combined in this cell. Okay, that cell combined will become BC whole bar. Take BC whole bar. No, there are two. Okay. Well, I think this diagram itself is wrong. First diagram itself is wrong. And then B and C. Oh, yeah. So we consider A plus B. So it is like A plus B whole bar. It will become A bar B bar. Okay. It will become what? B bar C bar. After what will it become? 2 plus means we take A bar common. B bar C bar. B bar plus C bar 2 1 plus will become A plus B C. And got it. This will be the answer. B will be the answer. B. Yes. That will look good because here if we consider B, okay, take A bar, we'll do this again. So A plus B. First we'll do plus and then after bar A plus B will bar to become A bar dot B bar. Okay. And this also will become B bar C bar. Okay. If again do plus C bar, take B A common A plus C bar. So you can common it become A plus B C. That's all. What is why we have so so yeah. So then what about food? This question is also in session familiar, but I'm sure this question also asking what this question asking. Okay. Okay, let me do first question. What is question? Consider the following expressions: A bar, C bar, A bar. Okay, AD bar plus AC bar plus VD bar. Okay, which one following expressions does not correspond to came back by the A bar expression? Okay. So what to found that correct? Where is people? See, take this down. Okay, wait. If we take this down, if we add, as I said, A is not present, right? A is not present. A, B, A bar, A bar, B, C bar D, F, A, B, C bar D. Okay, A bar, C D bar. Okay, so what is this? A, B, C bar D. Okay, it is present, but how do I check that? How to check this questions? Okay, so don't worry, the hard responder came up when you skills. So if you wanted to give up, we have to just multiply and do process can and so I had the first time to do. Just look at it. First, I have 10th question which is the literal count of multiplication expression in variable fraction in the sum of the number. For example, the literal count of x5 plus xz bar equals to is 4. Okay, we just count it programmatic. What are the main possible letters that have some expression access from cap? Okay, so what they're asking us just have to see if this get exactly give one, two, that's what 3 ones like this. So how can we take? So if we consider the whole corners, what we get? I got we get just odd corners. It's going to become my bar. It's going to become W bar, W bar. And what is this? Okay, here one is there, right? Here one is there. So going to do that here, one is there. So it's now always we just have to do these two things, right? That's what it will become, what will become. Map. What will become. But not true, it will be 11 out of 9. Yes, because it takes a minute of but 11 of zeros, okay, fine. So, I have to do this one correspond. Okay, what it exam is completed. I'm waiting for the answers. Okay, great. Oh, did not this have video of the visit? Change this one. So, fine. It will be good. When you to be good. So, what are they about? Okay, 53%. That's cool. Correct date wrong 3, 4th. So what I get wrong was this one. That's fine. Should not keep it and this is wrong. That's a D. And so yeah, wait. This can be POS, right? The the okay. What is it? Well, okay, zero, one more. Yeah, it's good now. So you must be public. Public or not. Next slide. It's public. So let me do this question. This is hard 80%. Okay, so I left this question. Let me do it. Get these questions done. We done 16 questions done and done 24. But and what this saying is minimum possible iterals count of POS and SOP respectively. Okay, first we have to find POS and then SOP. Okay, first POS and then SOP. But we need to have to put some filter, filter, and. We can see. So we have to do first. Okay, first we have to POS and then SOP next. These are the negative perspective POS. So first we have to SOP. So what SOP? What which there are one okay here. Okay, okay. So to make it possible. Right, to cover this one, we are doing this one and course we are doing this one. So why can't we do this one? So this one only, okay. And that's all. If we do this one, we will get what we get. It's called X bar, X bar, and here what is Z bar W. Okay, X bar Z bar W, and then what about this one? This one you nothing can do. This and what is this? This which come on. Z X Y and Z bar. So, go to corner, plus, plus, corner, we take these two, become y bar, and these two become w bar. Okay, now we put w. It did anything remain over now. So, what they gave us here, little one xy. So, here they counted two times. Okay, so for every literally so, okay, 1, 2, 3, 4, 5, 6, 7, 8. What? I'm getting 8, but there's no option. 1, 2, 3, 4, 5, 6, 7, 8. That's getting 8. Yeah, I have anything. I cannot leave everything. I have taken this one and okay, I have taken this one. So it's the possible. And okay, here we get 3. Here we get 3. 63, 6. And then there is no here is only set, that's all. So you look at 2, 3, 6 is 2. And here it 8. Why 9? How 9 becomes? Okay. I think I didn't follow the rule. We have to find, okay, we have to do the largest puzzle. So if it is, that means we can do this whole one. If we do that's okay, we follow the rule like it is some rules. Maybe not some rules. We have to group up the largest possible items. So if we group up these, it will come. We go. It will become what two terms. Yes. And if we do this one, if we do this one, what will it become 3 again? 3 plus if we do this, it will become 3, and if we do this one, it will become 2, and 6 plus 2, 8, 9, it will become 10. Okay, now 10. Why don't I just follow your rule? That's what it will become 10. So it will become 10, and there was POS. POS, we can do POS. And take one as zeros. Okay, putting these zeros here, two zeros. Here one zero, here two zeros, here one zero. Okay. So we these two will get what, two terms. Okay. Two terms, two terms, and these two will get with this whole will get this two will get again two terms. Okay. Two plus two. Four is here. We will get, if we take these two, okay, what will get this two plus three. Here we will get these two whole. That's good, plus two. Okay. 3, 5, 6, 7, 8, 9. Okay. 9 come up. So here the point we have to follow the largest one. Let us find, let us no need, right? It's again return corridors. This it's got to go. I just need to mark up what I so an important note is discussed here. Okay, two answers for the skip and three questions. Three questions. Simply conclusion is that 9 comma 8. Answers. Okay, answers 9 comma 8. Yes, I got the same. That's it. The question marker missed. Give wrong question. And some students are forcibly trying to match with the wrong question, but in future text gate question, the question marker won't miss it. So always follow the correct concept. Copies. Oh, that's that. So see, we are in the intro 8, but we have to do this. Okay. Question. I mean, not good question. Not the question. Okay. Okay, nice. Hey, we need not to solve the equation. It's really complicated thing. Big one. Okay, when he's okay. Yes, yes. Taking time. PS maintain one once in that case. You can use in that case zeros and first okay. Counters have been using it. Can't be using so big. Okay, some wrong views. Okay. Both these statements are wrong. Don't care simply miss, just don't care. We can say don't care. I think you're fine. So K-map grouping is not unique and the question size of minimum meter. The distance will be in 3 and 8 areas. Since there is no option get, we can go with 9 and 10. The question set up might have mislead grouping. Okay, let's say I think in ticket is more. It has a ticket wrong. This question. Okay. Now attempted. Right. Now that level attempted. Out of this level. mm, I corrected. I had a below 3 and one is now corrected and it's next question. Consider the following questions. AD word plus CC word which just following. The Lord, what should the kind of here? If you want to do that question, we have to note into standard canonical forms of K map, and we have to do K map and stuff. Oh, let's see what K map doesn't matter, but so then once solution here. Okay, so concept question IT. It is IT using K map, but it is solved by case method is good. Start with a variable that is more literal count. Okay, that's nice. Excellent, right? Oh, they don't need to do that one. So we consider, okay, and let us make this one. So how do we make this one? So A will be 1. If A will be 1 and this will be 0 and also B is also 0. Okay, let us fix this and C also 0 and D also 0. Let us put some corresponding code. Okay. A equals 1. If we take A equals 1, that's all. Option will be okay and option B also okay. Option A. Okay, what option? Okay, option A is okay. And option B. A body okay, option B is okay. Option C. A body okay, it's okay. Option D is stated false. Okay. So I think option D. Let me check the answer. Option D. Oh, one option C. It was a thanks. Got it. It's considered. Okay, there are it's not possible, right? 1000. Okay. Well, so D bar will be 0 and A bar C. Okay, A bar C. C bar will be 0. Okay, and B bar is 0. So what option C? In option C, so the equation does not correspond. Okay. It doesn't correspond, right? So what is this? A B here B is 0, but here B is 0. So it will be 0. Here C bar. C bar means 1. A bar means 0. Okay, here A is C is 0. Here B bar, C bar, D bar. Okay, here B bar, C bar, D bar. It's nice logic, man. I didn't see it. Okay, fine. So first of all, scale. So okay, we're make this 1. So what is make 1? Make 1 equal to 0. Okay. A B C D. First of all, 0 0. So all options. Okay, next. Prepare to make A is 1. Okay, and D is 1. Okay, D is 1. So if we make these two 1, what will get? We'll be eliminating these two. So what is C? C becomes 0. What is B? B becomes 1. Okay. Then this B C bar D is 1. Think so? Okay. Okay. If you not wrong, it will become 1. Okay. A bar. A means okay. D bar becomes 0. Okay, first one 0. A bar 0 and B C bar and D. Okay, and this is true. So let us check with this. So A here here it will be C bar D bar. C bar is 1, D bar is 0, is 0, and A is 1, D bar is 0, is 0, and it is A. B, A into B, 1, C bar, it is 1. Okay, this A bar says, what is this? A bar, C bar. What is false? And C bar, D bar. C bar, D bar, C bar, D bar, C bar, D bar. C bar, true, false, A bar, A, D bar. True, false, A, B, C bar. C bar means what? C bar. Okay. C bar means 1 and D. So that's nice. It is pass. And is A bar, C bar. Okay, A bar. Okay, it is true. Then A, B bar, 0, and A, B, C bar. Okay, here it has pass. So what about B, B bar, B bar, C bar, and D bar, 0, and D bar, 0, and A bar, 0, and C bar 1 is there. So C bar 1. So it is also, so all are passing. So what next? So what's what option make this one? What is option to make sense? So let us make a 0. If A is 0, then C bar. If A is 0, we have to make B and D is 0. Okay, and what we have to make? C bar is 1. So C bar is 0. Make these two. And I think only one will be the answer. So yeah, let's go with zeros. 0. So that's 1. So 1 it will become 1. What's the first option? A 0 and okay, it will be 1 and 2 1 and it will be not 1. So yeah, option C. Okay. Can I take questions? What the hell? Okay, just okay. No, I didn't ask. I just didn't comment it out. Okay, what I did. That's a question, but okay. So we're done with two questions and this question. Okay, and two and this question. So the question, what it is. Okay. What about this? This question is so long. Yes. And because we consider this to consider what we have to consider these two group of these two what we'll get. Yet here this one is common in this group, so one means here W. No, one means W bar. W bar plus here in this series count is going y plus W. Y plus W bar open system is and we have these two. So what where is 0 that 0. So we consider these two. We got get X. Okay. Yeah, I can consider this whole part, right? So we get X bar. That's why okay, okay. And what this? We group these two and also group these two. We group these two. This would have to get for 0x plus another phase answer. Okay, then so yes, I think it was okay. So one question. So what about this question? Let me figure this out. Even from the support product where K, and between video. So I'm gonna write this one. So we have to write this means what we get what B A dot C plus okay. Let me do this question. So wait. Which comes B C plus come B B is common. What C bar A bar plus C A. Okay. Then typically functions of from variable. I have to check. I have to check. This one take me as 0. I not have to check. Get 19. I don't have to check. Okay. I can't do a payment for which I should become. This is what that I got about BC plus BC bar A bar and plus BCA. Okay, if we simplify this, come what? Come B bar C bar A bar plus BC. Okay. Minimum effort. Okay. Entries with non-zeros are A bar, B bar, C bar, and okay. And text on this came up to variables, 4 cells, 8 variables came up. Okay. 8 cells for 8. Okay, no, 8 cells. Yeah, we'll expansion. Okay, if we do like this, ABC, okay, from the resultant. Learn and count, learn, count that to composition YouTube. This question can be easily solved watching temperature with many more variations. Okay. Representative, yes. P4 C. Okay. I just done the same method. Then what will become? It will become ABC. Oh, ABC. No, no, this is true. Right? ABC plus if we take these two, what will it become? B consider these two, we consider B, C will get C plus C bar will get cut. BC plus BA plus zero. BC plus zero could be positive. How we will not strong. Take C bar common, get A bar. BS okay. BS common become AC bar plus No, but we just consider this, we get B over suddenly functions sort of things. That's what's this lecture? Lecture is on the books of it. Let's continue. Which is it is what this is what function of this what definition. It is this okay, let's see my hand. No. Oh, still five questions. It's two or I got around 8 marks. 15. So my rank was 5 out of 12. Pretty decent itself. Fine. The total will take us. After 12, my rank is 5. That's fine.
Hi everyone, welcome to Go Classes. In this session, we will study Shannon's expansion theorem. Let's see what is this Shannon's expansion theorem. Based on this theorem, there is a GATE exam question. You can see this GATE IT 2006 question. This question is based on this same concept, Shannon's expansion theorem. So we will solve this question also. And we will do the complete analysis of this question. We will properly understand this question, and also we will see what are the variations possible for the future GATE exam. Okay. Now, let me tell you that these three topics, they are same. All the following topics you can see they are same. Means compact truth table, this concept, also Shannon's expansion theorem, this concept, and also decomposition of Boolean function. These three concepts, they are basically correct. Now let me tell you that this same expression, this is your function f. Now this same expression we can write, we can get in a different way. Okay, so let me tell you how to get this same expression in a different way. Okay, so let's see. The different way is like this. Notice what you can do. You can write this equation, this expression for function f, you can write in a different way, and that is like this. For this combination, for this input combination, the function value is 0. So I can say that for this combination, a bar, b bar, for this combination, the function value is 0. Or you can see for this combination, the function value is 1. So what I can write? I can write that for this combination, the function value is 1. So I can write a bar, b, 1. Or for this combination, the function value is 1. Okay, so what I can do? I can write that for this combination a, b bar, the function value is 1. Or for this combination, the function value is 0. So I can write for this combination, the function value is 0. Now you tell me, this equation and this equation, are they same? Basically, are they same function? Tell me, this function and this function, are they same function? Yes, of course, they are same function, because you already know that this will become 0. Okay, this is going to become 0. You already know that this is going to become 0. So finally, ultimately, what you are going to get? Ultimately, you are going to get a bar b or a b bar. Okay, and that is the same thing here. Okay, that is the same thing here. So this is how you can write the expression for a function. Did you understand? Let me know. Very simple. For this combination, the function value is 0. So you can write a bar b bar 0. Okay, a bar b bar 0. Similarly, for this combination, function value is 1. So you can write a bar b 1. Okay, and so on. Okay, like this. So you will get the same equation. You will get the same function. Okay, very simple. Now, let me give you another example. Consider this function, for example, if I give you 1110. Okay, this is another, the function value is 1. Simplify. Again, you can notice from here, you can get the expression also. This function expression also I can get. Okay, how to get it? Tell me. Very simple. When b is 0, then function value is a. Okay, so when b is 0, b bar a. Or when b is 1, function value is 1. Okay, is this clear? Now, same functions. Yes or no? Is this clear? So again, you can see very simply that this is your function standard truth table. Okay, is this clear? Now, okay,
Yes. Zero. What's something? It's only natural, but trees with shares, it becomes okay. That is function. Oh yeah, like you can just for it, say become a bar, a like a string. So fitting. So okay. Okay, next.
With respect to variable a,
Let's take another account. It's a hard case. You must be like, yeah, again, it's like it is okay. It's okay. It's my friend. Just his face keeps smiling. Sun, maybe. Why is not going on? Yeah. What is the other one? Well, we need to check out this question. This could be the field. This could be the field. Fine. So, yeah, that's one. Next. What is the conclusion? Okay, wait, I need to see the conclusion. Array. Line. So the conclusion is A bar B bar W and A bar P X and A B bar Y and A B Z. Yeah, it's true. Okay. Okay, what I've done this in right. So where is the question? I had done what? Then there's like if we want to guess this term, we just need to B C A bar. B C A bar. Okay, wait. Okay, this is not C, this is C bar. Okay. C bar is C. Okay. Common B C A bar plus C A plus B C. Okay, this is what I got. What it asking the Boolean function is sum of product with chemical description. So what will this here? ABC plus KBC. Okay, so then what next? Let's see what's coming. Here is paper, right? Here is see what's explain this kid. Okay, ABC is okay, but yeah, it's correct. Right. See, what is silly stupid mistake. This is where I got stuck. So now it's a completely wrong. It's not just silly mistake, but it can cost me that. Okay, so if you do this and become B bar, C bar, to become B, C bar, A bar, that's why they're writing this is the MS, right? Okay, anyways, yeah, so this term is something. So how can we simplify? Take C bar common, so become B bar plus B, A bar. it is not healthy. So if we simplify like this, it's just conscious theorem. We can just system can be cancelled. Cancel if we want to expand b bar plus b, b bar dot b plus dot plus into this. Right, true. Okay. It will be plus b bar plus dot into b bar plus a bar will become c, which will become 1 into anything will be 1. So finally will be c bar b bar plus c bar a bar plus a b c. Okay. So do you know it all this stuff? Okay, so what we are about Simmons theorem. Is this Simmons theorem? Okay. Okay, so what is this? Same. If a bar plus will become here to become a plus a dot a plus b bar. Okay, here it is a component a plus a plus b. Fine. So okay, conscious theorem property. Happy set property. Happy set. Because this every term should repeat 2 times, and one must be complement of error. So the answer will be complement term, and these two will be left out, and CB will be so bad. Happy set property. So next one. So it's not okay. I need to focus on. Okay, this is true. So answer I guess I get it will become 0. So you can write d1 plus t. Okay, fine. And no. Example of multiple x upon plus x dash become multiple f of x into x dash of x. A equals to a plus of 0 and into 1. Of a b will become of let's or maybe push right. This like it there. Yes. So when it's good, but I have silly mistakes to look just about it. And so I just okay, I just got cleared with using this 8 question and this total 11 question and for 60 question I done 1 question. So left 3 questions left. For questions let's do that 3 questions. So I think the 2 questions um, based on I thought it was that yeah, based on implicants, essential prime implicants and prime implicants. I think so. Here's one question on this, and this question is wrong. Why is the question option D? Next question. Question will get what expression will be. If you group of these terms, we'll get what? We'll get what is the common argument? A plus. And if we just do these two, we get another common here. Will C. Okay, C. Here common will be B. Okay, B. Okay, this is the expression to get output. Okay, as output. So here it can say step false. We consider B A plus B whole world. This is not a first R and not the B. It will become what? Become A for dot B for the same for BC. So it will become what will become plus B for dot C. Okay, dot C bar. Okay, here we're taking B bar outside, man. Yeah, man. So B bar X. So I think if this is here, my stupidity. Okay, anyways, I will be working. Fine, if we take this. That's it. And I've spent over 2 minutes for 10 seconds. Okay, it's not that much hard question, but it is. Okay. It is hard, but take 4 minutes to spend 4 minutes. Fine. And this question, you are good, get to get a 20%. Okay, so you take a lunch. This is the right. And that day, at night, if I'm having this, can choose what's enough. Okay, now the time is 10:57. I will do revision. Okay, so okay, I will do what I left it only implications. Need to make note of it. Yeah. Right. Good, it's good. Just I believe that 1 p.m. live ends, 11 p.m. live ends. In my head, it's so bad, but it's okay. Brilliant is so attached to it. Let me should continue. So, but visible. So, just okay. What else let me study about normal forms. So, which way to follow volume 2. A normal database is in volume 3 laboratory. So, database. Okay. So, I think I studied this normal forms. So, what is this after okay, flexibility? Augmented matters. I mean, augmentation and transitivity. And it's practice. Practice mode has a question before revealing. Okay. Okay. And so B-tree. No. Can it? Okay. Can key is a minimal super key. Okay. So this and you can keep properties. I think this also super key. Super key. doesn't require minimality. Yeah. But minimality. I'm going to check the minimality. Okay. For the subject, I think level of fitness into six. I think K is super key. If K plus contains are at one subordination, for example, key identify those all meaning that is no subset is also a super key. So conflicts is pretty choose concept legal. She is conflict. Okay, fine. So from class C and C, if cycle, then not conflict. Yeah. If cycle is present, okay, cycle, C was the periodic conflict. So precedence graph means what is nodes is transaction. What is yeah, it is transactions, and this edges are conflict. So the conflict, I don't know spellings, but I don't find it. It conflict or right, it's something conflict. There are only three conflicts here. So retreat is not a conflict, okay? So then HTJP, TJP, okay. Conflict. So I know only about conflict, but conflict serializability, but in serializability, but conflict serializability, diffuse serializability. I just know about conflict, but views I will learn it, okay? Okay, so the construct sequence graph and critical conflict with words of where Apple DFS then what such graph so which is integral also okay, common pitfalls, poor choice of primary and foreign case. Okay, so not adequately normalizing this schema leading to operator complex. Role not complex space prop, problems solving technique to start with the anti okay. Yes, these are yeah, this concept is very important. So database not normalization and what along this topic. So it's called database formation here. Systematic process of reconstructing a relation database to minimize data redundancy and improve data integrity. It involves decomposing relation into smaller, well-structured relational based on okay. Find from or something. Okay. In one enough, all attributes must be atomic. Okay, means should not have multi-valued attributes or composite attributes. If they exist, then we need to increase forward. For example, there is a tends to PC. It is appear as right. For example, there is A tends to BC, then it will can decompose into A tends to B, and A tends to C. I think so. But what exists? AB tends to C. Mm, it's on to this side. Multi-value component. Okay, what is okay? That is two enough means one enough and no prime attributes is partially dependent on kind of thing. Alright, and this thing okay, it's like this. Because first a video and the video is to with I not itself. But so was an info fast like a few hours. So just left with only 30 minutes. Okay, fine. To close this. Where is six and predicate this start study this okay this normalization. There are five so one can analyze so one can needs to be in Yeah, so with that, okay, for the answers or the different same table for it's sometimes the information stored in relations like information is to get the time. If one number is more better around which you can balance the one that is similar to that. What keep contains of attributes attribute groups its versions nonsense to communicate. On the left, okay, okay, fine. So the reactions, function, cascade, etc. all depend on differential referencing tables. First, the table has one given reference relation number two. If it violates, if violation happen with that, system has to reject violation. Violating modification always. Okay. FS equals the same bank name. Okay, if these functions are defined in schema, so all possible instances must satisfy them. If the instance will not satisfy, likewise then schema does not satisfy. This can also be defined between a fact. Suppose means whenever you combine is same two tuples, the same must be same, but the same is also but the same is not the same funky construct. A B tends to C, A B tends to C D, A B C D. Okay, fine. So we can't determine anything. Okay, suppose consider the relation between partial differences. So the following pattern is also solution. It should be. It should be. It has to be. It sounds always having. Okay, the same value is on different way, so that's all. It's from different. It has to see. Yeah, can be. It may be. It has to see. It's only wrong, so something can be connected by anything. We may not have quite just an instanceless single entry. So, but this is remaining for definitely doesn't have to know. Empty is depend on the schema. So all following instances that's a empty. Trivial empty, non-trivial empty. Okay. Trivial means what? Trivial means a relation with data stream gives. Okay. Creately and trivial means to X subset from if and only which is not subject to y, which in non-trivial means X and Y are unique. The areas limits given with all of here can find value of two yes. And that's what's in every instance. Simulation okay, it's true. So it's next. So whether we have this only have can determine it because of this which is appears. Not that this one depend over the schema will be in relation or in express is entry then what is x Okay, actually, super okay. It's in relation or if express is entire or okay. Okay, express entire but explain super key. In relation skin super key. Super key can only express content. Okay, but okay, if X is minimal, then it is candidate key. Okay, they not even exist what. Okay, fine. So express export super key. If X is C key only, okay, express for X is more egg or X is more than okay. Relation of zero that's how what we got connected to produce business. Okay. So training if access certificate next way is never candidate. Okay, if access candidate, the next way is convert into you can do super key. Combination of one candidate key with another other keys will always lead to super key. Okay, trick by absolute. If if they ask about they ask only super key, then find candidate and apply inclusion exclusion principle. Okay. Let us say let us imagine about grouping the dot on each. Far as the now CV set 3, so APG, so now equal to perfect. But if there is APG, then how many? Let us just do one simple math. Some simple math, it's the given equation A, B, C, G, H. Okay. And we found that the figures are A, comma, B, comma, G. Okay, now they're asking how many super keys are there. Okay, suppose 1, 2, 3, 4, 5, 6. There are 6 places to it. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. So in this place, A or B or G. These three must come. So how many possibilities? 3 C always. So what to be correct? Of these three, oh, oh, running what is this? This one is be filled in. Okay. That is the question. So, if we consider layers here, then how many ways we can fill this? In 2s, 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 2s. Okay, if it is constant, we are so what we have to just manage to find putting your given one call of functions. Doing the achievement It just to be, it just to be. Yeah, second stage is written CP to student you know, catch. People that's successful. Got it. Check. Check. Okay, thank you for your little bit. Okay, thank you for your little bit and Christmas and that's true. Yeah, is it partially? Okay. Fine. I just want to say that it's the other abstract. It's the other abstract. And